Hello guys, welcome as we look at this problem. Guys, I read the question. The radius of the two semicircles is 3. Find the area of the shaded region. And so guys, we have these two semicircles. This is one of them and this is another. Guys, you can see the distance between these two straight vertical lines is 3. And therefore, if the radius, guys, is 3, it means that this distance from here to here should be equal to 6. And so, guys, now we come to do the question. So I have some details here of that question. And the first thing, guys, you are going to do is to find the area of the intersection. And the intersection, guys, is this part here at the center, bounded by the two curves of the semicircles. And so I write now the equation first. The equation for that is 2r squared cos inverse d over 2 over r minus d all over 2 square root of 4r squared minus d squared. And from there now, we have r of the semicircles, remember, is the same, it is 3. And the d, guys, as you can see, this being the center of this circle, then it means that the d is supposed to be 3, because this is the center of this circle and this is the center of this circle. So the distance is 3 between them, between the centers. And therefore, guys, now we work out that. So the area of the intersection is going to be equal to 2 multiplied by, that is 9, 2 squared, 3 squared. We have cos inverse 3 all over 3 here. This comes to now 1/2 minus, this is 3 over 2 square root of 4 multiplied by 9 is 36 minus 9. And so, guys, this is what we have. And now we can come and do the calculations. When we do that, this first figure comes to 18 point, that is from the calculator, 496. Now minus this other one comes to 7.7942. And so therefore, guys, our value then of the intersection is now going to be, you subtract that, this one comes to 11.0554. So guys, we have that. Guys, now we come now look for the shaded part. So we have the shaded part right here. For us to get the shaded part, let's call it AS, where S represents the shaded part. Guys, we are going to say the area of the rectangle, and that is rectangle 6 multiplied by 3, minus, now we come and subtract. First, we subtract, let me just put a bracket here. Sorry guys, we don't need the area of the rectangle. We need the area of the union, that is AU. Guys, the union is any part that is touched by the semicircles. And that includes the shaded region and the area of the intersection. And so we say area of the union minus, guys, now we subtract the area of the intersection. So guys, that's how we are going to find our area. And so therefore, we shall have AS equals to The area of the semicircles, the two semicircles, guys, for one semicircle is a half pi r squared, and therefore for 2, it is going to be pi r squared, like that. But remember, guys, the intersection is counted twice. If you are to shade, guys, for example, let me just come here, and you go ahead and after getting the area, you shade it. If I shade this area like that for the first semicircle, guys, and I come and shade this other area, you find that I will have calculated the intersection twice. And so I need to get rid of that intersection, like that. So guys, this is the area of the union. And now guys, now we come and take away the area of intersection to get the shaded now part. And so therefore, you have AS equals to pi r squared. This comes to 9 pi. That is 9 pi minus the area of the intersection, which is 11.0554. All that, guys, now you come and subtract again 11.0554. And with that, we are going to have area will now be equal to 9 pi minus pi, that is 11.00554 minus 11.0554. Guys, this comes now to minus. You multiply that twice, comes to 22.1. Guys, for 9 pi is supposed to be 28.26. Now minus 22.1. And therefore, guys, this comes to 6.16. This is now units square. So guys, this is the area of the shaded part. Thank you guys for listening to me. Bye bye.